Hi, and welcome to this video. In this video, I'm going to be teaching about the binary search, and it's one method on how to search through a sorted array. I am going to be teaching the syntax in Java, but the concept itself is same throughout the coding languages. So if you don't know what a binary search is, you can still stick around and learn. You would need to know print statements, variables on how to declare variables, and how to manipulate them. You'd also need to know for loops, arrays, while loops, if, else if, and else statements, and you could know methods. You don't have to because you could put your binary search into a method, but you don't have to know methods to understand the binary search and to create your first binary search. So I've been saying the word binary search a lot. So what even is it? What does it mean? The binary search is a quick way to search through a sorted array for a value, and each iteration eliminates about half the array, or at least half of the remaining array. And it only finds one of the values that it's searching for. At least that is what I'm going to be teaching you today. That syntax for how to search only one of the values that's what I'm going to be teaching today. You could manipulate the binary search just slightly, or maybe you'd have to do a more in-depth changing depending on what you're using the binary search for if you want to find multiple values. But today I'm going to stick to only finding one value. So to help you understand exactly what the syntax is or how you would approach this, we're going to look at a dictionary. Dictionaries start with A and they end with Z, and they're all alphabetical order, so we can call it a sorted array. What we're going to do is that we're going to try to find the word coding, but if we went through the first word and we're like, oh, A, that's not my word, next word, that's still not my word, next word, that's still not my word, and you went through every single word until you found your word, that would take a long time, especially if the word was at the end of the book, like zebra. So the binary search is a much, much faster method. So let's try to find the word coding using the binary search. So we know that the word can be from the beginning of the book to the end of the book because we haven't started searching yet. So we're going to say that the first value is A and the last value is Z. Then we're going to find the middle value, and that is M. And we say C comes before M. So that means that our word is in the beginning part of the dictionary. It's in that A through M section. It's not in the M through Z section. So we could ignore that for the rest of the process. So now our first value is A and the last value is M because we know it's in between it. So we find the middle value again, and that's F. And we know that C comes before F. So we again move the last value to F because we know our word is between A to F. Then the middle value is C, and C is equal to Z. So now you got to the C section. Then you can continue with the next couple of letters, saying CA is the first value, CY is the last value, CM is the middle value, CM is less than CO. So you know it's in between CM to CY, and you don't need to care about the CA to CM. Then the CM is the first value, the CY is the last value, and CR is the middle value. And you know CO is less than CR, so you can ignore that second part and you move the last value to CR. So you search from CM to CR. And then in the middle of that, you get CO. And CO is equal to CO. And then you can just continue searching like that until you find coding. So if you didn't quite understand what we got or what we did, you can look at the right portion of the screen. So when we were trying to find the word coding, we first opened to the middle of the dictionary. We looked at the current word we're at, and we said, well, is it before or after what we're trying to find? And based on our answer, we moved the first or last value, and we repeated the process. In general terms, you can say you start with 2 pointers, and the value is always in between. So you can find the middle value and determine whether it is greater or less than the value you want. And based on the second bullet point's answer, you could change your pointer and continue searching. If the dictionary was a little too confusing, I have a little more simpler example. Let's say you have an array 1, 2, 3, 4, 5, and 6, and you're trying to find the value 4. So you have pointer 1 at the first index of the array, and you have pointer 2 at the last one. And then you find the middle value, which is 3. You're not going to find the average of the two. In this one, you just go down to the 3 because we're dealing with index and you can't have a decimal index. And you say, well, the value in this index, which is 3, is less than 4. So you have to move this pointer to the middle value plus 1. And you plus 1 because you already searched through this value. Like you already looked at it and said, oh, it's not the value I'm looking for. So you don't have to re-look at it again. So you can move it to 4. Then the new middle value is 5. And 5 is greater than 4. So you're going to have to move pointer 2. And just for simplicity, I'm not going to move it to 4 because then pointer 1 and pointer 2 will be in the same value. So I'm just going to move it to 5 for now. And then you find the middle value of these two, and that's 4. And 4 is the value you're looking for. So you're done. So I hope that is a little more simpler, and now that you get the binary search. Now onto the syntax. But before we go into the syntax, we need to think about the binary search just a little bit more. Like, what happens if the value isn't in the array? Well, when this happens, this pointer 2 will eventually be to the left of pointer 1. And that means that you've searched through the whole array. So then you can just exit and say, oh, we didn't find your value. I'm sorry. And what if the array isn't originally sorted? Well, that means you're going to have to sort the array first. And you could do it through selection sort or insertion sort or maybe bubble sort. But you'd have to sort it before you do the binary search. So this is a possible syntax, and yes, the syntax is in Java. So first we're going to declare an array. If you're using this in the real world example, for example, let's say you're trying to find a contact, then you might already have the array declared somewhere else. But for right now, we're going to say that this is our array. Let's say that we're trying to find the value 3. What we're going to do is that we're going to say the index of the first value of the array is always 0. And the last pointer is going to be the length of the array minus 1. Because if you remember, arrays start with index 0 and they go up to length minus 1. Then the middle value will be the first value plus the last value over 2. So you're finding that middle index. And you'll make sure that it's an integer. You might want to typecast it just to make sure, and you probably would do that. So remember when I said this first pointer here is always going to be on the left of pointer 2 unless we already searched through the whole array. So meaning we can use that as our while loop to make sure that we're only searching through all the values. So we say while that first value is less than or equal to that last value, if the array of at index middle, so the value at the middle index, is less than find, meaning that the value here is less than what you're trying to find, meaning that it's somewhere in this portion of the array, then you're going to move that first index to the middle plus 1. So that is what we did here, right? 3 is less than 4, so we moved pointer 1 to 4, which is this index plus 1. If it's equal to, then we'll just print out saying that we found your value at this index, and then we're going to break out of the while loop because we don't need to search through the rest of the array if we already found what we're looking for. Hint, hint, this is probably, if you're trying to find duplicate values, you might want to manipulate that part of the code. And for our else statement, that's when this value is greater than what you're looking for, which is this point. So you're going to move pointer 2 to the middle value, minus 1. And then if we ended it there, that would lead to an infinite loop because we're never redeclaring the middle value. So you would say middle is equal to first plus last over 2. Then once you exit the while loop, either if you found the value and you broke out, or if it wasn't in there and you couldn't meet the while condition anymore, then you reach this if statement, which is like if first is greater than last, meaning that if you didn't find it, then just print out saying, oh, sorry, we didn't find your value in this array. So let's try to program this. So here I am in the coding environment, and what I'm going to do is that I'm going to declare an array. So int var, and I am using Eclipse for this, so if you don't have Eclipse, please go to your Google browser, type in Eclipse download, and it should be your first result, and then walk through the steps it gives you. So what I'm going to do is that I'm just going to declare the numbers 1 through 10. And the first value is always going to be the index 0. The last value is going to be the array.length minus 1. And let's say that we're going to try to find the value 5. So I'm just going to say in 5. Then we're going to say that the middle value is equal to the first plus the last value divided by 2, right? Because that's the middle index. And if you wanted to, we could typecast this just to make sure that it's always an int. And it doesn't give us an error saying, oh, it's not an int, please change it to an int. So then we're going to say while the first is less than or equal to the last value, we're going to say if the value at array of middle, right, is less than the value that we're finding, that means that if this is the middle value and it's less, then that means it's somewhere here. You're going to have to move that first pointer. So we're going to say first is equal to mid plus 1. Else if they're the same value, then we found the value. So I'm just going to system.out.println, we found the value find at index mid. And depending on what program you're coding, you might want to do something else, but I'm just going to print out the index of that. And then I'm just going to break out the while loop so that we don't continue searching for no random reason. And then the else statement is when this value is actually greater than what you're trying to find, so that means it's somewhere here, meaning that you're going to have to move the last pointer. So last is equal to mid minus 1. Then you're going to if you just ran this, then it's gonna go in an infinite loop because you're never changing the value of mid. So what we could do is that we can reassign mid to the new value first, plus the last value, new last value divided by 2. And once we break out of the loop, there's two scenarios. We found the value or we didn't find the value. So if we didn't find the value, that means first is greater than last. So in this scenario, we're just gonna system.out.println. Sorry, we didn't find in this array. And if we run this, say we found value 5 at index 4, if we did a value that isn't in the array, like 12, then it says, sorry, we didn't find 12 in this array. And that's because the last value would come before the first value, because the first value would continue moving and it'd have to move out of the array, and meaning that the last value would come before first. So then just fixing period. So I really hope that you found that interesting, and I hope that you can use this in your coding. Enjoy!